In this video, we're going to talk about writing functions, piecewise functions, to represent real-life situations. The first problem we have is an electric utility company charges residential customers a $6 monthly fee plus 4 cents per kilowatt hour for the first 500 kilowatt hours and 8 cents per kilowatt hour for usage over 500 kilowatt hours. So the first thing we should do is think about what the piecewise function would look like. So our piecewise function is made up of parts. And are there two different parts here? The company charges a different amount depending on your usage. So let's call it f of x for fun. What would be the first piece of this? Well, we have the $6 monthly fee plus 4 cents per kilowatt hour. So that one's pretty easy. $6 fee plus 4 cents per kilowatt hour. And that's only going to be what they charge if, what would be the smallest kilowatt hours that fit into that scenario? Well, that would be if you didn't have any, which they wouldn't charge you for anything, up to the 500. Now the second piece is going to take a little bit more thought. It's 8 cents a kilowatt hour for usage over the 500 kilowatt hours. So our slope will change after that point, but we have to take into consideration where they were already. So let's kind of think this through. How much would they have already been charged by the time they got to the end of that 500 kilowatt hours? So if we look at the 500 kilowatt hours, 6 plus 4 cents for the 500 kilowatt hours. How much has the customer already spent? 6 plus 4 cents times 500, I get a total of $26. So they already have to pay what for that 500 hours. That's $26 for the 500 hours that they've already used. Now, for the additional hours, it's going to be 8 cents a kilowatt hour. But it's not just going to be an X in the parentheses, and let me talk about why that is. If I was up to 600 kilowatt hours, I can't just plug in the 600 here because this already took in consideration the 500 already used. If I was using, so I wouldn't have 600 that's being charged at 8 cents, how much would it be charged? Well, 500's here, so it'd only be the 100 that's over would be here. And one way I can represent that is X minus 500. So now let's see. If I had, say, 700 kilowatt hours, This takes care of the first 500 right here, the 26. So if I had 800 and plug that in, 800 minus 500, that would give me 300 hours being charged at this fee. So it works. And that part of the function is for when we are over, well, we could say when x is greater than 500. The 26 takes care of the first 500, and then we're charged 8 cents per kilowatt hour after that. So let's look at what that graph would look like. Okay, so this is my X. This is electricity used in kilowatt hours. This is the monthly bill. Oh, sorry, monthly bill. So let's say we do, I'm going to count by fours, it makes it easier. 8, 16, 24, 32, 40, 48, and 56. And down here, let's count, oh, by 50s. 50, 100, 150, 200, 300, 400, 500, 600, 700. Now, what's the easiest way to plot some points here? Well, we know we can start but with this one at the y-intercept because it starts when x is 0. So here would be my y-intercept, 6. It's right between 4 and 8. That's easy. Now, this one is a steady increase until we get to 500. Now, what would be the output when x is 500? Well, we already plugged it in right there. 6 plus 4 cents an hour for 500 hours was 26. So here's 500. This would be 32. So 28, 26. So somewhere right about there would be $26. And remember, you really only need 2 points to draw a line. So I'm going to see if I can find a ruler real fast, or a straight edge of some kind. Found one. Now, I don't go past this point because this is when my x value is at 500. Now, let's see if we can pick another point, maybe, because this one's going to start changing. That slope is changing to 8 cents an hour. So what if I picked another point, say 700? So what would happen if I plugged in 700? Well, that's in that second category because that's over 500 hours. So 26 plus 8 cents for 700 hours. Now remember, whoops, this is already taking care of the 500 hours. So the 8 cents is only being charged for the 200 hours that's over 500. So now 26 plus 8 cents times 200, and that's $42. Okay, so here's 700 goes to 42. Now, it could keep going up because I could get 800 kilowatt hours, 900, and so forth. So my line isn't going to stop at 700. It's going to keep going. So I would have a little arrow to show that it keeps going. Now let's try writing another piecewise function. In this piecewise function, I have a day ticket for a ski lift, costs $25 for children at least 6 years old and less than 13 years old. A day ticket for students at least 13 and under 19 is $45, and a day ticket for adults at least 19 costs $60. So again, we have pieces. Everybody's not being charged the same rate. So let's see if we can write a function for this one. As creative as I want to be, I'm just going to call it f of x. So let's think about the different prices that f can be, that our cost can be. Well, we have $25, and it's a set rate. For children at least 6, so at least 6 means they can be 6 years old, but that's the youngest age they can be, and less than 13. From 13 to 19 costs $45. So this one says at least 13. So 13 is included here, but they have to be less than 19. And $60 is if we're over 19, at least 19. So that means 19 or greater. So what would that one look like on a graph? Well, what can you tell me about these? Well, there's no slope. It's just a single output. When there's no x value there, there's nothing changing. That means we're constant. So we're going to have horizontal lines. And we can kind of go over that as we go over the graph. So here's my x-axis. What is the x-axis representing? Well, that's my ages. Age. And the y-axis, or the f of x axis, is actually my cost of tickets. Cost of day tickets. So let's see. We need to get past 19. So how about, let's see. 1, 2, 3, 4, here's a 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, and so forth. Going up, well, how about let's go 10, 20, 30, 40, 50, 60, and 70. So, the people under 5, there's nothing happening there, right? When you're 6 years old, how much are we charging you? Well, that was $25. So, 6 years old goes up to 25. 7 years old, whoops, that's not really a 6, is it? 6 years old, 7 years old is 25. 8 years old, 9 years old, 10 years old is still only getting charged 25. All the way up to when you turn 13. Even if you are 12 and 11 months, you're still going to be charged at $25. As soon as you turn 13, they're now going to charge you $45. and I know my graph it's not lined up. I should have done graph paper. All the way up until when you turn 19. So even if you're 18 and 11 months, you will still be charged $45. As soon as you turn 19, they're going to charge you more. They're charging you $60. And then 20, 21, 20, 25, 40, all the way along, you're being charged that $60. So these are a couple of examples of how piecewise functions can represent real-world situations.